Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on June 30th, 2025, just a few days ago. This paper proposes a fundamental paradigm shift for AI, moving from models that just look at images to models that can actually think with them. The paper is titled, Thinking with Images for Multimodal Reasoning: Foundations, Methods, and Future Frontiers, and it lays out a fascinating roadmap for how AI might evolve. It argues that current models are limited by text-based reasoning and outlines a new three-stage evolution towards true visual cognition. Also, the authors shared a fantastic GitHub repository to accompany their survey. In it, you'll find a comprehensive collection of papers and resources, all neatly organized by the key reasoning stages they outlined, from tool-driven exploration to intrinsic visual imagination. It's a great starting point for anyone interested. Alright, so this first figure visualizes the paradigm shift they're proposing. It contrasts the old way, think about images, with the new, think with images. Currently, large multimodal models, which are AIs that process both text and images, tend to reason only with text, but the proposed evolution has three stages. First, tool-driven exploration, using a fixed toolkit. Then, programmatic manipulation, where the model writes code for custom analysis. And finally, the ultimate goal, intrinsic visual imagination, where the AI generates its own visual thoughts, like a mental scratchpad. This table of contents then shows exactly how the research is structured around that three-stage evolution. You can see that sections 3, 4, and 5 are dedicated to each stage, from tool-driven exploration all the way to intrinsic visual imagination. Within each of these stages, the authors explore different implementation methods. These include SFT-based approaches, which stands for supervised fine-tuning, a process of teaching an existing model a new skill with specific examples, and RL-based approaches, which use reinforcement learning, a trial-and-error method where the model learns from rewards. Okay, so this next figure gives us a really detailed taxonomy, a kind of family tree for this whole thinking with images idea. The main trunk splits into three big branches. The first branch is that three-stage evolution we've been discussing, from tool-driven exploration to programmatic manipulation, and finally to intrinsic visual imagination. For each of those stages, the diagram branches out further, showing different methods like prompt-based, supervised fine-tuning, and reinforcement learning. The figure also maps out related benchmarks, frameworks, and a whole host of applications, from medicine to robotics. Building on that idea, this next figure breaks down exactly what those operational stages look like in practice. In stage 1, tool-driven exploration, the AI uses a fixed toolkit. For instance, it might use optical character recognition, or OCR, which is a technology for reading text directly from an image to check the age on a toy box. Then, in stage 2, programmatic manipulation, it gets more advanced, writing its own code to solve problems. And finally, in stage 3, intrinsic visual imagination, the model generates new images as thoughts, like visualizing the steps to make toast. So this next figure really showcases the power and versatility of this whole paradigm. It lays out 7 different domains, from mathematical reasoning and STEM problems to real-world applications and even puzzles. And in each case, you can see the model actively using the image as a workspace. For a geometry problem, it draws extra lines to find the solution. For a visual illusion, it adds dotted lines to check perception. And for a puzzle, it actually visualizes the next steps, drawing out the path to solve it. So as we've seen, this paradigm of thinking with images is incredibly powerful, moving AI from simply looking at an image to actively using it as a cognitive workspace. This paper lays out a clear path for this evolution, from using external tools, to writing code, and finally to pure visual imagination. The ultimate goal is a unified visual thinker, but there are still big challenges in efficiency and safety to overcome. It's a really exciting frontier. That's all for this week's AI Research Roundup. I'm Alex. Thanks for listening.